Welcome to Grade 7 Mathematics. In this lesson, we explore the geometry of lines and angles, the language we use to describe shape, direction, and turning. By the end, you will name the building blocks of geometry, measure angles, and use the rules that connect them in parallel lines and triangles. Here is our plan for the lesson. We begin with the building blocks, points, lines, rays, and segments. Then we describe what an angle is and measure one with a protractor. We use angle relationships to find missing angles, study the angles formed when a line crosses two parallel lines, and finish with the angle sum of a triangle. Geometry starts with a few simple ideas. A point marks an exact position. It has no length and no width, and we name it with a capital letter. A line passes through 2 points and extends forever in both directions, which we show with an arrow at each end. A ray has one endpoint and travels forever in a single direction, like a beam of light from a torch. A segment is the part of a line between two endpoints, so it has a fixed length we can measure. From these pieces, every angle and shape is built. An angle is formed when two rays share a starting point. That shared point is called the vertex, and the two rays are the arms of the angle. An angle measures the amount of turn between the arms in degrees. We sort angles by their size. An angle smaller than 90 degrees is acute, like the one shown here. An angle of exactly 90 degrees is a right angle, a square corner. Between 90 and 180 degrees it is obtuse, and exactly 180 degrees forms a straight line. Knowing the type tells us roughly how big an angle is before we measure it. To measure an angle exactly, we use a protractor. First, place the center of the protractor right on the vertex. Then line up the zero line with one arm of the angle. Now read the scale where the second arm crosses it. Here the second arm crosses at 60, so the angle is 60 degrees. Always check that you start from 0, not from the wrong scale, because a protractor shows numbers running both ways. If the angle looks acute, your reading should be below 90, and that quick check catches most mistakes. Angles often come in pairs that follow neat rules. Two angles that add up to 90 degrees are complementary. Together they form a right angle. Two angles that add up to 180 degrees are supplementary. Together they form a straight line. When two lines cross, the angles directly opposite each other are equal. We call these vertically opposite angles. And angles that share a vertex and an arm sitting side by side are adjacent. These four relationships let us find an unknown angle without measuring it. Parallel lines run in the same direction and never meet. We mark them with matching arrows. A line that cuts across two parallel lines is called a transversal. It creates several pairs of equal angles. Angles in matching positions at each crossing are corresponding angles, and they are always equal. Angles on opposite sides of the transversal between the parallel lines are alternate angles, and they are equal too. So, once we know one angle, the parallel lines hand us many of the others. Triangles hold one of the most useful rules in geometry. The three interior angles of any triangle always add up to 180 degrees. In this triangle, the angles are 65, 70, and 45 degrees. Adding them gives 180, exactly as the rule promises. This means if we know two angles, we can always find the third by subtracting their sum from 180. The rule holds for every triangle, whatever its shape or size. These ideas are all around us. When a carpenter builds a roof, the timbers meet at angles that must be measured to keep the structure strong. Where roads cross in Kigali, each junction forms pairs of angles, and engineers use these to design safe intersections. On the football pitch, a pass travels along a straight line from one player to another. Even a clock teaches angles, as its hands turn through 30 degrees for every hour that passes. Geometry is the quiet language behind the things we build and use. Before we practice, let us avoid the traps that catch most learners. First, When measuring, read the scale that starts from 0 on your arm, or your answer will be wrong by the difference from 180. Second, keep a ray and a line apart. A ray has one endpoint, while a line has none. Third, do not mix up complementary and supplementary. Complementary angles add to 90, supplementary to 180. And finally, the angles inside a triangle must total 180 degrees, never more and never less. Keep these in mind and your geometry will stay accurate. Here is a quick summary of the key ideas. Points, lines, rays, and segments are the building blocks of geometry. An angle measures the turn between two rays meeting at a vertex. We measure angles with a protractor, always starting from 0. Complementary angles add to 90 and supplementary angles to 180. When a transversal crosses parallel lines, corresponding and alternate angles are equal, and the angles inside any triangle add to 180 degrees. Now, let us check how much you remember with 3 quick questions. Here is the first question. An angle measures 35 degrees. What is its complement? Complementary angles add to 90 degrees, so we subtract. 90 minus 35 is 55. The complement is 55 degrees. Question 2. Two angles sit together on a straight line. One is 118 degrees. Find the other angle. Angles on a straight line are supplementary, so they add to 180. We subtract. 180 minus 118 is 62. So the missing angle is 62 degrees. Last question, and this one combines 2 ideas. A triangle has a right angle of 90 degrees and another angle of 40 degrees. Find the third angle. The angles in a triangle add to 180 degrees. Subtract the 2 we know, 180 minus 90 minus 40. That leaves 50, so the third angle is 50 degrees. Wonderful work. You can now name the building blocks of geometry, measure angles, and use the rules that connect them, from parallel lines to the angles inside a triangle. Take a moment to practice a few problems on your own. In Module 7, we build on this to explore triangles and congruence. I'll see you there.